So we've all seen this quote, premature optimization is the root of all evil. This is a very famous quote, but I think today it's often abused to mean as an excuse to not worry about performance. We can worry about performance next week. We don't need to pay for that this week. But modern apps, the performance is really important for user experience. And I don't think that that's what Donald Knuth meant. I think what he really meant is don't optimize before you measure. In fact, the Google ad team found that 53% of mobile site visits are abandoned if they take longer than 3 seconds to load. So 53% is a lot of customers, and 3 seconds is not a lot of time. So performance is really vitally important. And if you're like me, you've probably worked on a project where you had to optimize a product after the fact, after it's already been deployed to production. And it probably took a long time and was difficult and expensive. And this beautiful Excel chart is meant to demonstrate that the longer you wait in the software development lifecycle to optimize, it's going to get exponentially more expensive to do that work. So given those considerations, my quote is that not measuring performance is the root of all evil. So when you're working on an app, the first thing you need to do is develop a measurement plan. And we don't need to do this from scratch. We don't need to reinvent the wheel. I like to follow the Rail model, which was developed by Paul Irish and Paul Lewis at Google. It's a pretty simple model to follow. And today, we're going to apply this model to an app and optimize an app. And so this is the world premiere of Sparkle, the app. It has a unicorn, and if you click on it, it'll sparkle. I'm supposed to get some audio here. This maybe. Sound flower, I don't even know what that is. There we go. Okay, so let's look at what we want to take a look at. The first thing we want to look at is load time. Load is when you initially load the page or when you're transferring between views. You want to load in a second or less. That doesn't mean your whole app has to be up and functional. It just means you have to have something on the screen that the users can see and be able to interact with. The next part of Rail is idle. Idle is the time when your browser isn't doing anything. It's not running JavaScript. It's not handling user interactions. It's not fetching data. You can use this idle time to prefetch resources and do background tasks so that when a user performs an interaction, everything is ready to go and there's nothing that you have to wait for. Response time is probably the most important for most apps. I guess it depends on what kind of app you're working on. If you're working on a more content-based app, load is probably the most important. But if you're working on an app with lots of interactions, response time is really key. And basically what this is when a user performs an interaction, you want to respond within 100 milliseconds. Users perceive a delay between their action and the response if it takes longer than 100 milliseconds. Now, if you take over 500 milliseconds, you should probably show some type of loading indicator. But there's kind of a gray area between 100 and 500 milliseconds because if you pop up a loading indicator and then take it away, it can be kind of distracting. So what you want to do in that middle ground is a bit fuzzy. And the last part is animation. So most browsers run at 60 frames a second. And what they do is they run your JavaScript, they render the page, and then they paint it to the screen. So that cycle, if you want to maintain 60 frames a second, takes 16 milliseconds. That includes the stuff the browser is doing, like render and paint. So in your JavaScript, you really only have about 10 milliseconds of time that you can use before you start dropping frames. And that includes any framework code like React or Angular. So that's really what makes writing JavaScript hard, is that all of your code has to execute in less than 10 milliseconds, or else you need to split it up into chunks so that your application doesn't get janky with a low frame rate. Okay, so given that, here's our plan for our Sparkle app. We want to load and render our app in 1 second. We want to respond to the Sparkle command in less than 100 milliseconds, and we want to animate the sparkles at a good frame rate. So here's our unoptimized app. You can see that it took a while for that unicorn image to load. So I'm going to open the dev tools here and take a look at why that might be happening. Looks decently big. So if you select the Performance tab in Google or in Chrome, it'll give you some information that's very helpful. So I'm going to hit record and then refresh this page. And at the top of the screen, you get a timeline. And if you move your mouse across it, you can see screenshots at any point in time. So if you move the mouse far enough, we'll see that the unicorn shows up at 5 seconds, which is pretty dang slow. So to investigate this, the first thing you're going to want to do is look at these different bars under here. Each of these sections is basically a different thread in Chrome that's running. And the first thing I can see is this big bar right here. That looks interesting, so I'm going to expand it. It says image decode 1 second. So that doesn't look good. Looks like it has something to do with the image. I'm going to pop over to the network tab and take a closer look. And if I look at the unicorn image here, you can see it's 7.9 megabytes, which is probably not great. This is like super retina. We probably don't need it on like cheese grater projector. So the first optimization that we're going to make is we're going to reduce that image size. In this case, I'm just going to use the source set and sizes attributes on the image tag. This allows you to load resolution-dependent images so that we can load the appropriate sized image. And in fact, this falls into a broader set of techniques when you're optimizing load time. Anytime you're looking at load time, accessing static resources over the network is a likely culprit of slowing down initial load time. And that's a whole nother talk into itself, but some of the things you can do are making sure you minimize count and size of files, properly configuring cache headers, using e-tags, configure compression, using HTTP2 like Daniela's talk, and use a CDN. Okay, so here's the next version of the app. We got rid of that horrendously large image, but you can still see there was still a lag before the unicorn showed up. So I'm going to switch back to the performance tag and we can take a look at what is going on. Okay, so if I move my mouse, it looks like the image showed up in about 1.5 seconds. So that's much better, but still not really all that great. So again, I'm going to look down at the different bars underneath here, and I see that there's something in main. Main is basically all your JavaScript code that's executing. All of your code, all your framework code, it's going to all show up under main. So I'll expand it here. And I can see the functions names. I have create audio and buffer audio. And it turns out that these have to do with loading the audio that plays with the animation. This is the code the way it looks now. And this is sequentially loading resources. It loads the bitmap, waits for the bitmap to be loaded. Then it fetches the audio, waits for the audio to be ready, and then renders the app. So anytime you see code like this is a possible place where you can do some optimization by parallelizing the code. And in the next example, we just throw it into a promise.all so that we fetch the bitmap and the audio at the same time. And then when we render the app when they're both ready. In this case, we can go one better step than parallel because we don't actually need the audio until the user clicks the Sparkle button. So we can go from parallel code to lazy code. In this example, we fetch the bitmap, we immediately render the app, and we don't actually load the audio until the user clicks the button. So this is that example. You can see there was no lag in loading the actual unicorn image there. And if I refresh in my performance tab, you'll see that it loads in about half a second. But now I'm going to have another problem, and that is when I click on it, I mean, you can't really tell when I clicked there, but there was a delay in playing the animation because it had to fetch the audio. So if I record this, we can take a closer look. OK, so you can see Chrome kind of automatically zooms in to where you are when you record an interaction. And you can see that down below if you open the Interactions tab. You can see the user interactions. In this case, here's the mouse up after I clicked, so you know this is when the event was triggered. And if I move my mouse over, you can start seeing the sparkles right about there. So there's a whole there's about a whole second there between when I clicked and when the animation played, which is really not great. Remember, we want our response below 100 milliseconds. And to fix this, this is where our idle time comes in. So we can use the time when the browser isn't doing anything to load and process the audio so it's ready to go when the user makes the interaction. So in this case, we fetch the bitmap, we immediately render the app, and then we use request idle callback to go and fetch the audio. Request idle callback is a really nice function that basically tells the browser, hey, do something whenever you're not busy. It's not supported in all browsers, so you'll need to fall back to request animation frame or set timeout to do that. OK, so here's our optimization with the idle. We have the unicorn and the app rendered quickly. I'm going to record the interaction now. OK, so if we look at the interactions here, this is the mouse up. And let me see where we. There we go. So you can see that's not. So it's responding quickly to the actual user interaction. But you can see that now we have a slow frame rate. So we need to fix that. And if you look in Chrome, they have a nice helper here for debugging frame rate. So I'm going to record this again. Hopefully no one from Skittles is watching this. You see these red dots at the top. These are Chrome telling you that there are slow frames. And if you are interested in kind of one metric to determine is my app performant, it's probably frame rate. Because anytime your frame rate drops, your users are probably having a bad experience. So that's one thing that's really easy to measure. And if you drop down, the next section in Chrome actually has a frame drop down. And if you move over, you can see what the frame rate is. In this case, our frame took 157 milliseconds to execute, which is 10 times too slow. So we want to fix that. So if you drop down to main, again, I see these functions getting executed, and I see these little more red dots from Chrome. This is Chrome telling you that you're probably doing something not so great. And anytime you're dealing with a problem that's related to JavaScript execution time, the easiest way to figure out what it is usually to use the bottom ARP chart at the bottom. The bottom ARP chart sorts JavaScript functions by the time that it took to execute those functions internally. So we have this calculate bounds function at the top. It took 754 milliseconds out of however long this span I have highlighted here is, which doesn't seem great. So if we look at the code, this is the code that's animating the particles. We're looping through each particle, and within each loop, we're calculating the bounds. And then if it's in bounds, we're animating the particle. So obviously, in this case, we want to try to call calculate bounds less. So we're going to move it outside of that loop and call it fewer times. So now, in the end, we end up with an optimized app. It loads quickly, it responds quickly, and it animates quickly. But in real life, you're going to have some complications. So I'll admit, you might not believe this, but it's actually pretty difficult to develop a farting unicorn app that's slow because it doesn't do much. So I actually had to engineer some slowness into the app. So your actual applications that you're working on will be much more complicated and difficult to debug than just the simple rules that we looked at. But you can still use the Rail framework as a way to measure what you need to optimize and identify where you need to target your work. In the real world, your users aren't going to have a corporate Wi-Fi connection, and they're not going to have the latest hardware. So something that Chrome provides is network and CPU throttling that allows you to simulate other devices. Also, in today's modern JavaScript, we often have complicated tool chains, including Babel and Webpack. Those tools have about 1,000 different knobs you can twiddle with, and many of those knobs will affect your performance. So it's really important that you understand your Webpack and Babel config and keep looking at it regularly in case, make sure someone doesn't commit something that suddenly degrades your performance. A great tool for that is Webpack Bundle Analyzer. It'll tell you what libraries you're including, how they're getting in there, and that'll help you remove code that you don't need. Make sure any debug configs are disabled. And both Babel and Webpack have a host of optimizing plugins. There's just a bunch of them, so if you want to get into this, you'll just need to read through them and determine what works for you and what doesn't. Webpack is supposed to support tree shaking, but it doesn't really work. Tree shaking basically eliminates unused code. So if you want that feature, I'd recommend using Rollup, which is an alternative packager. Another good tool to analyze your site is Lighthouse, which is now built into Chrome. If you go to the Audits tab here, you'll see Lighthouse, and you can do perform an audit. You'll want probably performance and best practices. This will run against any website and then tell you if there's anything you need to improve with it and what your performance is looking like. Another really good tool is if you want to track performance over time, like if you want to run a performance test after a commit to see if something changed, or if the performance is degrading or getting better over time as web page test. It's an open source project from AOL and Google. There are also some commercial tools built on top of it that make it a little bit easier to use. And that's a super great resource for running tests. They run in a VM, and you can use them. You can run them with different devices and different browsers and see what happens. There are also some framework-specific tools out there, tools like React Add-ons, Perf, and ng-stats. These tools are really great for debugging and fixing an app, but they're not so great for identifying if you have a problem or not. So I'd recommend using the tools inside of Chrome and web page test to identify if you have a problem. And then once you know you have a problem, these are the tools you can use to help figure out how to fix it. So I hope you all go out, optimize your apps. I work at freshtracks.io. Come check us out. If you want to find me, search for LimsCoder. And if you want to find these slides, search for React Present.
is...
All right, are you ready?
I don't know, am I?
All right, so you talked about how the longer you wait, the harder it is to fix your performance. What would you consider low-hanging fruit that you should just start to tackle and chip away at?
I mean, I would say the first thing you should look at is static resources. That's usually the easiest thing to chip away at. A lot of people have bad configs for loading static resources. And probably the second thing is making sure your Webpack and Babel config is all good. And your React config if you're using that.
So would you say that if we decided to use, canned API responses, we'd get rid of the bottlenecks?
Yeah. So your website's just always the same, it never changes?
Yeah, I mean, cans don't have necks because they're not bottles.
Gotcha.
Sorry.
Cans are pretty popular now.
Don't clap for me. You're enabling it.
All the microbrews in Colorado are going to cans.
Oh, let's talk about that.
Yeah, do you like film festivals?
Film festivals?
Yeah, cans. Okay. I'm an adult.
Only when they're the movie Hackers.
Yeah, that was a good movie. What's your favorite scene in Hackers?
Oh my gosh.
Hack the Planet?
Hack the Planet's pretty good. I like the ridiculous outfits, I guess, is the best.
Yeah.
The red vest was pretty good.
Yeah, the Marty McFly look.
Yeah.
He was looking pretty Marty McFly. Cool. Well, thank you so much. We really appreciate it. You just followed Jessica off, and we're going to introduce...